which one is it?
Inconsistent. Oh, I thought you had to do like math or something.
Alright, I'm hearing answers. Seeing students look back at what they wrote down Friday and reading the answer there. Yeah. Just to review what I told you. So, number one, I guess before I start, I can just go ahead and review the vocabulary words I'm looking for. So, if the lines cross in one place, the solution will be an XY ordered pair. What's that called? The fancy vocabulary, Gabby? No, I'm not talking about number one. That's the answer to number one. I'll write that down. Oh my God! Did you say consistent? Yeah, I was reading wrong. No, consistent's right. Consistent. Yeah.
That's 2 out of 3.
That's right. Consistent. If they never cross. If they never cross, meaning they're parallel lines, just like number one, that's called inconsistent. Yeah. Oh, okay. Okay, my bad. I want to say the next one. The next one. If it's the same line, Eva, what's it called? Consistent dependent. Consistent dependent.
But number 2 is consistent independent.
So when I say use the vocabulary from Friday, I'm looking for this, or this. So, number one. Yeah, number 2 is consistent. Let me try that again. Inconsistent is also described as no solution. And what that means is there isn't any one point that these lines have in common. They have no points in common. Number 2, what's the answer, Torian? Inconsistent. This one. Consistent. Independent. So you were absent Friday, or you were just trying to remember Friday? Was anybody absent Friday? Okay. So what's the solution to number 2? What's the actual ordered pair? -2, 1. Oh. It's hard to see where you're at. No big deal. And then number 3, you have to graph this one yourself. So there's 2 different strategies for graphing that second line. So I'm gonna go ahead and graph the first one.
What?
So I would start for the first line at 4 and go up 1 over 2. So I'm gonna graph both of these lines, hoping to find where they cross.
Oh, is that a question?
This is y equals 1/2x plus 4. No, that's what I'm doing. I'm graphing them both. So the first one set up y equals mx plus b. Ready to do that. Okay, so for this line, we could we have 2 options. Two options to graph. I hope you guys can start to realize that you have options when it comes to graphing. This is standard form. So we could possibly find the intercepts. Or we could put into y equals mx plus b form. So when you're looking at an equation and you're trying to figure out the graph, these are your 2 options. You have both of these tools in your toolbox moving forward. You should be making this decision. Do I want to get y alone so that I see slope intercept form, or do I want to plug in 0 for x, plug in 0 for when I find intercepts? Who wants to find intercepts? Raise your hand, top point. Who wants to get y alone? Raise your hand, top point. Okay. Let's get y alone. So we're going to do the work to get y alone. So I would subtract x from both sides. I put the x before the constant because I know that's just how I want to line up my equation. Divide both sides by -2. And y equals -x minus 8 over -2. A lot of negative signs there. Let's break this fraction up into two fractions. I could do -x over -2 plus a -8 over -2. It's starting to look like something I can graph. So two negatives make a positive, and you wouldn't have to show all this if you guys are breaking this up, in a quicker way. This would be x over 2 plus 4, which is the same as 1/2 x plus 4. Same line. When I go to graph that, comes out the same.
So that's consistent.
Is that what it's called?
I think so.
Consistent dependent. So let me say this as well. That means they have infinite solutions because there's an infinite number of points that the top equation and the bottom equation have in common. It's a consistent system, and the two lines are dependent. They're the same thing, dependent. Infinite solutions, consistent, dependent. So sometimes your equations are disguised. They're equivalent, but they're not in the same form, so you don't recognize it right away. So this is pretty much a full review of what we did Friday. I know you finished your workbook in class. Just open it. I'll walk around quickly to give you credit for doing it.
That movie was so long. I fell asleep so fast. I could not look at it. Huh?
Or like read about it.
It's so boring though. Like nothing was happening. Someone's on trial. Like that was. I woke up from the kid getting killed.
Which one? The one with the red hair? Would you different because they look the same?
All I remember is that little kid getting killed.
Someone got killed?
Little kid, right? He got ran over from one of the. Yeah, that's the part I woke up. No, that was at the beginning.
The words in pink. If you didn't put the words when I walked by, I'm gonna say add those words, please, and I'm not gonna even try it unless you do.
You know work. I did it. This is ridiculous. This is ridiculous. You got it? Oh, I did this wrong. Did you just get your nails done?
So look at the answers.
Hang on.
Check them. Not everybody has all three right, so you should be making corrections.
What'd you say?
Does anybody have a question?
No, ma'am.
I'm giving you a 0 for your homework. I you to correct it, and you're trying on your phone. You're not doing what you're supposed to.
Anyway. Yeah, Holly, the liquor thing was at the beginning. No! The kid kept ran over and like.
Dude, I said she just laid there.
Oh,
Yeah.
this goes by two.
Okay, we probably
The liquor thing was in the beginning.
I remember because that one was 15 and it's hard to see.
He stood in front of the.
Oh, because I didn't. You guys are not helping me. And then
And like with Lucy.
oh yeah. I know. I'm just waiting for one right here.
Yeah.
I'm like, what?
Yeah.
It's actually right here.
Oh, okay.
It's 14, 15.
He's like, I'll run and went over. It was funny.
Oh, I think they simplified it too.
It was so
Like
dumb.
making it go by 5 or
And it's 3 hours long. This shit was you want to do something after school? Can I come with you? Because I want to buy Crocs. I want to buy Crocs and then I want to get a pearl necklace. But Kaylee doesn't know what they are. If I can go, I've only gone. What time are you going? I have to drop Tyler. Okay. I'm so tired that I can't leave. I didn't give you money.
Alright, so same section of the textbook. Yeah, no, same section of the textbook.
We have to get our textbook now.
I keep on thinking it's August.
I hope I did my bottom work. I did it last year. Okay, if you don't shut up. Okay. It did last year.
What page is that on?
How do you think I know?
No, use hot pink.
I used that one last time.
Then use green.
Bright neon.
Neon yellow like your melon.
That died like a while ago.
That was so bad. It's just like super blue.
Okay, pick a color for you this time.
Green. Light green.
Alright, so because this is a review of algebra 1 and geometry, they're putting these 3 topics into one section of the textbook, and technically I could have gone all 3 of them in one day, and some of y'all would have been just fine with that, but I know a lot of you need the time to take it one day at a time, so I'm doing that. So in solving a system, you can graph, but graphing's not always logistically right. Like, sometimes you can't see where the lines cross, and you have to make an enormous graph. And sometimes your lines cross, like, in the middle of a grid line, and you have to, like, estimate the solution. And so if you don't want to estimate, and you don't want to graph, you can use this other method to find where 2 lines cross. The substitution method. So in substitution, you start by solving an equation for one of the variables. What that means is get x alone or get y alone. I mean, this is right out of your book. So some of you guys know this well enough where I'm not going to make you write it. Some of you don't, but you should probably write it. straight out of page 138. So this step 1 means either get x or y alone. You can pick, so solve one equation for one of the variables, get x or y alone. Step 2 is where the substitution comes into play. Substitution means replacement, right? So substitute the resulting expression into the other one by replacing the variable and then solve. And then lastly, substitute to solve for the other variable. I'm going to put a little note there. You want to make sure to find x and y. So your first 2 steps will help you find either x or y. And that third step will make sure that you find the point. A point where 2 lines cross, that requires an x, y coordinate. So make sure to find them both. We're doing 3 problems together, and you're working independently. So where do these lines cross? We could graph them, but this looks like a doozy to graph. That's not going to graph well. It's a doozy. I don't want to graph that. This method's actually quicker. Substitution's quicker than graphing usually. So for number 1, step 1 is to isolate x or y. Well, the second equation gives us y isolated. So y equals negative 2x plus 7 is given. So we already have a variable isolated. So we can go to step 2. Step 2 is to actually substitute. So here's my first equation.
Oh, wait, what?
So I know what y is. Y is negative 2x plus 7. You good? You all right? I'm doing this problem right here. So I know what y is. So I'm going to take that top equation, and I'm actually going to take this y out. And I'm going to take this, since it tells me what y is, and I'm going to put it in. You haven't done it yet. I promise it's easier than graphing. Give it a chance. You haven't even done it. Let's not label it until we've tried it.
That makes a lot more sense.
Yeah, let's put it in parentheses. Torian.
Okay, so trying to put it in context. I know this is a property of some kind, just can't remember what it is. Where it's like A equals B and B equals C, so you can say A equals C.
Reflexive property?
Yeah, that thing.
Yeah.
So this is pretty much that.
Yes, you could justify this with that property. Kaylee, write those down and finish it out. Oh, perfect. Let's do it. Is everybody good with the y going out? And then with everything is y going in? All right, now go ahead. Finish her up. Let's do distribution first.
We just made a difficult equation.
It's not so bad. It's
like
not
solving that whole
so
thing.
bad. Yeah. Go.
You have to distribute first. Then.
That's it.
So x equals 4.
Yeah. Yeah. x equals 4.
That's just too much work.
Alright, we're not going to forget step 3. So many students in Algebra 1, they first do this, they neglect step 3, but you guys are pros at this. You would not forget step 3. You have to find the other variable. So if you have x, don't stop. You must find y.
What does that mean?
So to find y, I'm just gonna put this x right into either one of the provided equations. I'll put it into this one. So if I know x is 4, I can put 4 here, and that'll give me y.
Did you just say not a yummy Y?
I didn't say that. No.
I was like,
No, it doesn't sound like my
I
lingo
swear.
at all. All right, so my solution is the ordered pair 4, -1. So this would be a consistent, independent system. And long story short, that is a little easier than graphing. That I didn't make you graph any equations that were too difficult, but I wouldn't want to put zeros in here and get these fractions and graph fraction intersects. I'll go with Matthew first. It'll look like it'll be the same slope. At the end, so like a no solution parallel line inconsistent, when you're doing this substitution process, it's going to look something like this. Like the variables cancel, and you'll have a contradiction, and you'll stop here, and you'll say this is a no solution. And you might even recognize that they're parallel lines and the same slope. Torian, what was your question? Yeah. So those would be the same line. So infinite solutions are all real numbers. When you do the process, it's going to look like this. A true statement at the end when the variables cancel out. I'll be sure to pull an example like this and like this for Ballard tomorrow.
For Bell.
Just like swap both of them and put intercept form in the beginning where you solve it and then you
Set them equal to each other.
Actually,
Don't do that. Don't do that. Do this. All right, go ahead and do number 2.
yeah. Did you just say try number 2?
Let's do 2.
It's too much.
All right, step 1 is to isolate x or y. Step 1 was done for us in the first one. Step 2, x is not by itself, y is not by itself in either one of these. So you get to pick which equation you want to work with. Caitlin, which one do you want to do? The top one. So if there's an equation where one of the variables does not have a coefficient, this has an invisible coefficient of 1, that's going to be your easiest one to isolate. Like this x is going to be the easiest variable to get along. And that's a decision that you have to make. That's critical thinking. So get x alone here. I'm going to put that tip here. If possible, pick an equation with a coefficient of 1. So x minus 7y equals 11. I am trying to get x alone. That's not going to be true every time. It's just true for this system. So I will add 7y to both sides of the equal sign. And I get x is 11 plus 7y. So I'm not using this equation anymore. I'm using this one because it tells me what x is. So step 2 is to substitute. So I come to the other equation that I didn't work with, and I substitute. So I know what x is, so this time I'm going to kick x out. And I'm going to take 11 plus 7y and put it in. Are we good on that? Replacing x instead of y?
Wait, so then it would be 5.
So in Algebra 1, I spent a whole day where the problems look like this, where y is already alone, and you plug in for y every time. But here you've seen it before, so we're going to have to just jump to a more difficult example. Take the x out and put the expression in. No, there's no like always here. There's no. You always have to get either x or y alone on one side. Either x or y.
Can you do like terms?
Yeah.
So, can I do 35y plus 4y? Gives you 30.
Yeah. Combining like terms. What does it come out to? I don't know. Oh, really? Pretty good. 39y equals -78. Sure. That is good. Divide by 39. This time we found y. Y is -2. Taylor, can you just put, Addison, can you put that away? All the way away. Do you know what to do, Stepher? Wait, solve it. Yeah, so we found y. So just a big reminder here, don't stop. Lots of students stop. They feel really good and you did a lot of work. Don't stop. You must find x.
Oh, wait.
And then
Yeah.
we would just make it into an ordered pair.
And then make it into an ordered pair, yeah.
And then that's substitution.
So x is 11 plus 7 times -2. So I take that -2 and I put it right there. And that helps me find x. So it's like it's double substitution. Substitute once, minus substitute again. So our answer, -2, -30.
No, wouldn't it be -3, -2?
Yes, it would.
What would it be?
Be really careful about that. If you found x second, put it in the correct
-2.
ordered pair.
Jesus.
Be careful. Other questions? Okay, I had a word problem planned, but I think I'm going to stop and give you your handout so you have lots of time in class to work on it. Yeah, you're not like.
We had a sub. What's up?
Wait, so what is this? Consistent?
No, yeah.
Oh, I think that is it.
Because this is called substitution. I knew when I wrote that. You were going to feel it.
Look, I thought it said
This is ridiculous.
So I picked this handout so that you could practice independently. The answers are here. It's a riddle type handout. You know, where you find the letter and then the riddle is, what did the boat say to the other